Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1455. It is a easy string question and this question has been asked in Yelp. So it is good for those who are getting started with their interview preparation journey. In this video we are going to have a look on 3 different easy approaches and you can use any one of them. Let's have a look on the problem statement. Problem says check if a word occurs as a prefix of any other word in a sentence. It's almost clear from the title itself that we have to check whether a word occurs as a prefix of any of the word in a sentence. Let's directly jump on the example. I will try to explain the problem statement using this example. Here we are given 2 strings. String 1 is a sentence and another string is search word. And you have to give me the index of any word from this sentence such that this search word is the prefix of that word. So this sentence string contains words which are single space separated. It is already given in the problem statement. And you have to return the index of the word which is having prefix as this search word. And the index should be 1 index. So if the first word is our answer, then we have to return 1. Okay, so what the problem is saying is that any word in the sentence start with search word. We have to return that word. So this is if you take this word and you start searching for every word in the sentence, and if you found any word in the sentence that is having search word as a prefix, then you have to return the index of that word. And you have to keep in mind that the index is 1 index. So the problem looks very simple. That whatever is given in the problem statement, we have to do that. What is going to be the first approach in this case? First approach is our manual approach, or you can say the brute force approach. Here what we will do is whatever given in the problem statement, search word. Search word is the prefix of any other word in the sentence. So what we'll do is we'll try to get every word from the sentence by manually iterating it, and whenever we are encountering a space, we will just start our new word. So later on, once we have all the words, I will iterate over words and I will match them with the search word. And if this word is matched, I will just return the index. So what I did is for all the words, first of all, I extracted all the words. Then check if any word start with the search word. If that is the case, that index plus 1 can be my answer because it is 1 indexed. Okay, so it's pretty straightforward. I'm not going to code this approach. Let's just quickly discuss the time and space complexity of it. What is the time and space in this case? Time is like, first of all, I iterated over this sentence and I splitted every single word. Let's say the length of this sentence is n. And then for every word, let's say I am having W number of words. Let me give you an example. Let's say these 3 words, hello 1, hello 2, hello 3 are from my sentence. They were a single space separated. I have added them into an array. Then I need to match word 9 and this is my search word. And let's say it is of length m and these are W in number. So in the worst case, it can go like every word is being mapped m number of times. Let's say for every word I am doing m operations, matching the first character, then second character, then in the end mth character. Okay, so in the worst case it will go number of words into length of the search word. So n plus w into m. So this is the time complexity. And what is the space complexity? Space complexity will also be order of n because we are iterating over sentence and storing it in a word. So order of n is going to be my space. So this is the time and space complexity in this approach. Now let's have a look on the second approach. In the second approach, we are going to use 2 pointers technique. In first word, first of all, I iterated over the sentence and then extracted out every single word in the word array. But we just have to compare the current word with the search word, whether the search word is the prefix or not. So we can do that while doing the iteration itself. There is no need to store it in a different data structure. So when I'm on the first word, I will just compare it with the search word. If it is matching, then return the index. Otherwise, try to move to the second word. When I'm on the second word is always starting with space. So there is a blank space, and after that there is a second word, blank space, after that there is a third word. So in this way, when I'm doing the iteration of a sentence, I will be checking whether I'm getting that final word which is having search word as a prefix. If that is the case, I will just return the index of that word, and yeah, I can return from the function at that moment. So instead of taking an extra data structure to store all the words, I'm just doing one iteration of a sentence. So in this way, we are just optimizing our space time. So in this approach, the time complexity will remain the same, order of iterating over the sentence and matching with every single word. So that can go in the number of words into the length of the search word. And the space complexity will be constant because we are not using any extra space to store our words. So this is slightly better than this brute force approach. But yeah, it will be more complex. Complex code involvement is there. So what we'll do is we'll try to take help from the inbuilt function. But you might say that using an inbuilt function is not a good idea. Yeah, that I understand. But this is only for the starting. When you are starting your preparation and you are getting your concept ready, getting familiar with the syntax of the current language of your choice, then it is good to implement every single thing by your own. But yeah, once you are comfortable, your logic is more important than your your implementation of every single thing by your own. So if we are utilizing inbuilt function, we might have more efficient algorithm and very cleaner solution. Whenever you use inbuilt function, you can assume that these inbuilt functions are built with a very high efficiency. So let's say if it is sorting or some other kind of algorithm, so the inbuilt function are always the optimized version. In the problem, we are given a sentence. Sentence is a string, and that string, first of all, we need to get string array. You can check over the internet whatever inbuilt function your language of your choice have. Let's say for reference in Java, we have split function that takes the input as a string or character, and it just split the given string based on that. So the sentence is splitted into the string array. This array we can call words. Now what I have to do is for every word I need to do some kind of processing. For every word I will do something. What I'm doing is that for every word W, I will see whether the search word is the prefix of it or not. If it is prefix of it, in that case, I will just directly return index, keeping in mind that it is one index. So if it is the 0th word, I will return 1. So let's say we have processed every single word and still I am not having any answer. In that case, I can return the default value -1. So this is my approach. The first thing is that I use the split function, and the second is that whether the word starts with search word. So I just utilize two inbuilt function and I'm able to write very clean code. Let's look at the time and space complexity. In this case, the time and space complexity will remain the same. Order of n plus w into m. Space complexity is not better than the two-pointer approach. It is order of n. But we are mostly bothered about the time complexity because our systems are very strong now. So they can handle very good quantity of time space. So okay, this is the time and space complexity, and what we achieved using inbuilt function. Our code will be easy to understand and maintainable because we are using only two inbuilt function. The whole logic of comparing is into the one expression only, and this splitting also the one operation. If you have to manually split it, just you have to iterate it, and whenever you are encountering a space, you do some kind of logic. So it is more cleaner and understandable. Okay, now let's try to code this approach. First of all, we will split the sentence into the words, and this we will split over space, single space. Now for every word in the words, I need to do something. If let's say it is a prefix, this word is having a prefix as a search word. If that is the case, I need to return the index. What is the index? I need to take it. Let's say this index for the iteration, it is starting from 0, and after every loop it is incremented. What I'm going to return is I plus 1 because it is one index. And if I'm not able to find the solution, I will return -1. Now I have to implement the prefix function, private boolean prefix, string word string prefix. First of all, I need to see if the length of the prefix is greater than word, then there is no need to check. If p dot length is greater than w dot length, in that case I can directly return false. Otherwise what I will return is return w dot starts with p. Let's check over sample test cases. Test cases are passed, submitting the problem. It got submitted successfully. I hope you have understood the approach and you can try implementing the other approaches as well. Thank you guys. Bye bye.